So what we're going to do today is to solve absolute value equations. So yesterday we talked about what is an absolute value equation. Today we're going to talk about solving them. So to solve an absolute value equation, you have to first isolate the absolute value. Next, rewrite it as two equations. Then solve. And finally, we have to check for extraneous solutions. So oftentimes everybody tries to skip the check step. And for the first couple of problems, I could see why. However, as we get into more and more problems, we're going to notice that we get what we call extraneous solutions. And if you refer back to yesterday's notes and definitions, that's a solution you get, but does not work when you check it. So we have to always check absolute values. So in number one, the absolute value is isolated. In number one, the absolute value is isolated. No, you can wait till I'm done teaching. Should have gone at the beginning. I said no. All right. We'll see when it's an emergency and I send you to the office then. Okay, we have the absolute value. It's fine. I'm just going to send them to the office. Of 15 minus 3x equals 6. You want to split into the positive and the negative. So an absolute value is equal to both a positive and a negative because the distance could be equally to the left or to the right of our equation. So for the positive, you just drop the absolute value. And for the negative, we set it equal to negative the right side. So we drop our absolute value and we make one side positive and one side negative. And now we're just going to solve exactly as we would solve an equation. So you're going to, on the left side, subtract 15. And then you are going to take 6 minus 15, which is negative 9. Divide both sides by negative 3. And we get x equals 3. On the right, in red, you're going to subtract 15. We get negative 3x equals negative 21. Divide both sides by negative 3. And we get x equals 7. Now, before we start on the next problem, we're going to just quickly check these. You check by plugging back into your original. So it would be 15 minus 3 times 3. And we want to make sure that equals 6. And then over here, 15 minus 3 times 7 needs to also equal 6. So you get the absolute value, 15 minus 9. 15 minus 9 is 6. Absolute value of 6 is 6. So x equals 3 checks. Yes. Yes. And then here you get 15 minus 21. So the absolute value of negative 6 is 6. So 7 also checks because one might check and one might fail. So then you have one solution instead of two. So absolute values, which is a great question, absolute values can have no solutions, they can have one solution, or they can have two. Okay, let's look at the next problem. So the absolute value is isolated. So we split into the positive and the negative. So you drop your absolute value, set it equal to the positive, drop your absolute value, and set it equal to the negative. Subtract 2 from both sides. Divide by 3. And we get x equals 5/3. And then on the right, subtract 2. And we get 3x equals negative 9. Divide by 3. And you get x equals negative 3. Yes. And then you take your absolute value. And the absolute value of negative 6 is 6. So I think so like the 15 minus 21, yes, is negative 6. That's what's happening right here. However, it's inside the absolute values because those are part of the original equation. So after you get that negative 6, the absolute value of negative 6 is 6. Okay. So in 2, so maybe this check will help. We have the absolute value, it's 3. You plug in the blue equation, which is 5/3 plus 2. And you want to see if that side equals 7. And you plug in the negative 3. So you have 3, negative 3 plus 2. And you just basically are doing the absolute values like we did yesterday, but now they're equal to a number, and you want to make sure those numbers equal. So you get 5 plus 2, which is 7. Absolute value of 7 is 7. So 5/3 checks. Here we get negative 9 plus 2. And again, you get the absolute value of negative 7, but the absolute value of negative 7 is 7. So it also checks. In these examples here, what happens is we have the absolute value being manipulated by other parts of the problem. So what we have to do is isolate the absolute value before we can split the problem. You have to isolate the absolute value before you can split the problem. So I need to get the absolute value of x plus 9 by itself. So to do that, I'm going to subtract 4. Divide by negative 2. And I get that the absolute value of x plus 9 is equal to 4.5. Now my absolute value is isolated, so I split the problem to the positive and to the negative. So you get x plus 9 equals 4.5, and x plus 9 equals negative 4.5. So I get x equals negative 4.5 and x equals negative 13.5. When you check, you plug back into the original. So it's going to be 4 minus 2, absolute value, negative 4.5 plus 9. And we want that to equal negative 5. So negative 4.5 plus 9 is 4.5. Absolute value of 4.5 is 4.5. So you get 4 minus 2 times 4.5, which is really 4 minus 9. 4 minus 9 is negative 5. So the two sides are equal. And on the left, you have 4 minus 2. Negative 13.5 plus 9 is negative 4.5, but the absolute value makes it a positive. And we end up with negative 5 equals negative 5 once again. I promise they do eventually fail. But again, we're still working on isolating and solving. So in number 4, you need to isolate that absolute value. So you need to get rid of the 5 and the 2. So we're going to start by subtracting 5 from both sides. Dividing by 2. And then once you have your absolute value isolated, then you are going to split the problem into the positive and the negative. Solve for x in both. So we get x equals 5. And x equals negative 13/3. Here's why leaving this in a fraction is way more helpful than changing it to a decimal. When you plug negative 13/3 in and you multiply it by 3, the 3's cancel. If you change it to a decimal, then it's a repeating decimal, and then when you plug into your check, it doesn't always check out nicely because you've approximated or rounded. Three times 5 is 15. 15 minus 1 is 14. 14 times 2 is 28. 28 plus 5 is 33. So 5 checks. And that's what I was saying here. The 3's cancel. You get negative 13 minus 1, which is negative 14. The absolute value changes that to a positive 14. And again, 2 times 14 is 28. 28 plus 5 is 33. Now, number 5 is different than the past examples. The absolute value is isolated. However, this time the absolute value is isolated but not equal to a number, but rather an equation. That does not change our process. We're still going to split to the positive and to the negative. The positive is always just the equation minus the absolute values. So we'd add 4x, add 4, for the negative side, you drop your absolute values. And in the past, it's just the negative or the opposite, the number. Well, for the equations, it's negative the entire equation. So you're changing the sign of all parts. So it's 3x minus 4 equals, since it was negative 4x, a positive 4x. Since it was negative 1, it becomes a positive 1. So it's the opposite signs of all parts. Subtract 4x. Add 4. And you get x equals negative 5. Once again, what we want to do is check to make sure these work. So I take 3/7 back into the original. Here's where a calculator is helpful. So 3 times 3/7 is going to give you 9/7. 9/7 minus 4 gives us negative 19/7, but the absolute value changes that to a positive. And on the other side, negative 4 times 3/7 gives you negative 12/7. Take 1 away, and you get negative 19/7. But does a positive 19/7 equal a negative 19/7? They're not equal. Therefore, 3/7 is that extraneous solution. It fails. It is not an answer. So you got to give me a big X next to it. And then you got to check negative 5. So 3 times negative 5 is negative 15. Negative 15 minus 4 is negative 19. But you're inside the absolute values. So on the left, you get 19. A negative times a negative is a positive 20. 20 minus 1 is 19. So we get 19 equals 19. So x equals negative 5 checks and is a solution. So again, in this case, we have one solution instead of two. In the past 4 examples, you had 2. Now we have 1. Let's look at 6. Absolute value is isolated. So we're going to look at the positive and the negative. So for the positive side, I have 2x plus 3 equals 3x plus 2. We're going to subtract 3x and 3. So we get negative x equals negative 1. So x equals 1. And then for the negative side, we get 2x plus 3 equals negative 3x and negative 2. Because you take the opposite of both. Add 3x to both sides. So you get 5x plus 3 equals negative 2. Subtract 3 away and you get 5x equals negative 5. Or x equals negative 1. We're going to check both of those back into the original. Two times 1 is 2. 2 plus 3 is 5. You get 5 equals 5. So positive 1 checks. Checking negative 1. You get 2 times negative 1 plus 3 equals 3 times negative 1 plus 2. So negative 2 plus 3 is 1. Absolute value of 1 is 1. You get negative 3 plus 2, so you get negative 1. So that means x equals negative 1 fails. That's an extraneous solution. So again, this has one solution. Where's my x minus 1? Okay, so we have the absolute value of x equals x minus 1. And what you want to do is, once again, split your problem into the positive and the negative. So you get x equals x minus 1 and x equals negative x plus 1. X minus x is 0. Does 0 equal negative 1? No, so that fails. We get 2x equals 1, so we get x equals a half. So now this time we got a solution, so we need to check it. So absolute value of a half is a half. And then a half minus 1 is negative a half. So it fails. Therefore, this function has no solution. Some of you like to do the 0 with the line through it. That's fine. But this has no solution. There are no values of x that will make that true. And then last, a standard adult tennis racket has a 100 square inch head plus or minus 20 square inches. Write and solve an absolute value equation to determine the least and greatest possible sizes. So we know it needs to be able to be 100 plus 20 and 100 minus 20. So we're going to do the absolute value of x minus 20 is equal to 100. So that's one option. Because then you could do 120 minus 20 is 100, or 80 minus 20 is negative 100, which would also give you 100. And if you solve that, again, you'd get x equals 120 and x equals negative 80. But we know that it can't be a negative for that length, so it would become positive when you solve it, knowing that it cannot be a negative length. Okay, your homework is the next page in your packet. You are doing just the front and the back. So it's 12 questions.